Hi, I'm Mark Taparowskis with Xamarin University, and this is Android 101, Introduction to Xamarin.Android. Please download the course materials before we begin. Once you do that, you'll find this document, starthere.html. It contains a complete description of the course, followed by a link to the lecture materials, followed by links to each one of the exercises. So for example, if I click on this first exercise link here, I'll get a complete step-by-step description and guidance for the first exercise. Going back, at the bottom of this page, I'll have links to some suggested additional reading. The other thing you'll find in the course materials are solutions for the lab exercises. So this course has 4 lab exercises. 3 of them involve coding, and so 3 of them here have solutions. If you drill down into these folders, you'll see a solution for each one of the parts. Our main goal today is to build a Xamarin.Android application. We're going to code both the user interface and some code behind. So for example, we might have a button in our user interface, and then we'll have some code that subscribes to the button's click event and reacts at runtime when the user touches that button. We're also going to discuss some theory. In particular, we're going to talk about what an activity is and try to get some intuition for about how big an activity is, just what's the scale or the scope of an activity within your app. And finally, we'll talk about how to keep your development machine up to date as new versions of Android get released. To get us started, I'd like to show you the finished lab exercise. So here's what you'll be building throughout the course today. It's an app called Tip Calculator that calculates the tip for a restaurant bill. So at the top there you have an input text control that lets you type in the amount of the bill. Then you have a button. When you touch the button, the code behind runs, it reaches into the UI, retrieves the amount of the bill, calculates the amount of the tip and then the total, and displays those 2 values down here at the bottom. So this is a fairly simple app, but it still demonstrates a lot of the common patterns. There's some user input, there's a button with a click event, and then there's some output to be displayed. Our first objective is to create a new Xamarin.Android project. We'll start off with a quick discussion of the features that are available to you to build your app, languages, libraries, development environment, that kind of thing. And then we will go ahead and create a new project. To start us off, here's the definition of Xamarin.Android app. So a Xamarin.Android app is an Android app, but one that's built using the Xamarin tools and Xamarin libraries. For your user interface, you're going to use the Xamarin wrappers around the underlying native Android views. For example, native Android supplies a button class. Since it's native Android, that button class will be written in Java. Xamarin gives you a nice C# wrapper around that underlying native Java button. You interact with that button using C# code behind. At runtime, what the user sees is the native Android button. So Xamarin.Android apps are native Android apps, and at runtime the user interface that the user experiences is going to look and feel exactly as the user expects because it is a native Android app. To build it, you get to choose between Xamarin Studio or Visual Studio. In either case, you get to use C#, including all the latest C# features, including things like async and await. F# is also supported. In this course, though, we're only going to talk about C#. When Xamarin wraps the Android libraries for you, they build classes that are going to look and feel familiar to C# developers. The Android native types are written in Java, and they tend to use patterns like get and set methods. So for example, here's a class on the left called editText. This is a text input control. It's going to have methods like getText and setText. When Xamarin wraps this class, they translate that into a property named text. So the usage pattern will be much more natural for a C# developer. The same thing's true for eventing. On the left-hand side, the edit text uses the add and remove listener pattern, which is common in Java. The Xamarin wrapper changes that into a text changed event. Again, much more familiar for the C# and natural for the C# developer. Inside your app, you get to use 3 different libraries. The first one is the Java libraries that come with native Android. So Android lets you use a bunch of Java utility types. Just as a simple example, something like string buffer, or even Java's version of things like ArrayList, the data structures. So those types of classes are in the Java Star package, and Xamarin provides C# wrappers around all of those classes. Perhaps more important than those, you get to use the full Android libraries. So in native Android, native Java, there's a bunch of Android Star packages. Xamarin has wrapped all those as well. So this is how you interact with the operating system. This is how you build your user interface. For example, that edit text view we just looked at and button, those are all things that would be in this category. You also get to use the mono version of the .NET libraries. If you want to, you can use these instead of the Java types for your utilities. For example, inside here you would find something like String Builder, if you prefer the .NET string experience over the native Android Java string buffer. So it's your choice. Most C# developers are probably more familiar with the .NET libraries and will choose to use the mono version. The Xamarin website has a page that shows you exactly which types are in the mono.NET implementation of the .NET base class libraries. When a new version of Android comes out, so for example, something, especially in this middle box, something there changes for a new version of Android that gets released. The Xamarin wrappers are usually released extremely quickly after that point, if not the same day, then within a few days after the Android release. You can also use third-party Java libraries. So any jar file or Android Archive AAR file that's targeted at building or being used with a native Android app can be integrated into your Xamarin.Android app. You do have to do a little bit of work because you're essentially calling from C# code out to Java code. So there's a little bit of work to make that happen. You can use either JNI, the Java native interface, or you can build a bindings library. In general, the bindings library is the recommended approach. It is a little bit more work up front, but it creates a nice C# wrapper around the Java jar file and therefore makes your access to that quite a bit easier. To create a new project, you're going to use either Xamarin Studio or Visual Studio. It's your choice. They both have an analogous set of templates installed. In our case, we're going to be building a new Xamarin.Android app. So we're going to go to the New Project dialog here, and we're going to choose something out of the Android category. We're building an app, not a library, so we'll choose the app subcategory here, and then Android app as the template. Our first exercise is creating a new project. Right, again, you can use either Visual Studio or Xamarin Studio. The course materials have complete instructions for this part. So if you'd like to work on this on your own, please go ahead and pause the video, work through exercise 1, and when you're done, come back and we will go over the solution steps. Here I am in Xamarin Studio. I want to create a new solution. There's a new solution button right here on the home screen. You can also do File, New Solution. Either way brings up the New Project dialog. On the left-hand side, we want the Android category, and underneath that, the App subcategory. We're going to choose an Android app. We're going to do this in C#. Notice there's a drop down there to let you select the language of your choice. Click Next. Use tip calculator as the app name, and everything else you can leave as the default values. You can choose where you want to put this. I'm going to go ahead and just put it on my desktop, and then click Create. So the starter template created a really simple app for us. In the resources folder, and then underneath that in the layout folder, there's a file called main.axml. And if I look inside there with the source code editor, I'll see a button inside a vertical linear layout panel. So the user interface here, the starter code, just has a single button. The code behind does a lookup to get access to that button, and then subscribes an anonymous delegate here to the click event. There's a field that tracks the number of times this button's been clicked. Every time you click the button, right, the button text gets updated with the new value. In this first objective, we surveyed the features that you can use to build a Xamarin.Android app. So we looked at the languages, libraries, and development environments that are available. And then we created a new project. We did it using Xamarin Studio, but similar steps are available in Visual Studio. Our second objective is to talk a little bit about the architecture of an Android app. And this discussion applies both to native Android apps and Xamarin.Android apps. So we'll first define what an activity is, and then get a little bit of practice thinking about, for a couple of sample apps, what kind of activities you might find inside it. So an Android app is often described as a bunch of activities that work together to achieve the goals of the application. And if you look inside an application, you'll see a structure something like this. There'll be several activities where each activity is a grouping of UI plus code behind. And then kind of off to the side, you'll see extra files, images, data files like XML and so on. So that whole collection of things makes up an app, but notice the core component really is activities. So an activity is the combination of user interface and code behind to let the user do one single thing. So a single task that the user can accomplish. In this example, I have an activity to compute the value of pi to some number of digits. On the left-hand side, you can see the user interface. Right? The user types in the number of digits they want and then clicks the button. So that's the user interface part of this activity. Behind the scenes, there's some code that actually does the work. So those two things together, the user interface on the left plus a bunch of code, more than what you just see there, but a bunch of code behind, right? Those two things grouped together make up the Pi activity. Here's another example, this one from the Android email app. So the email app is decomposed into several activities. The first one there on the left would be something like your inbox. And you'd have a list of messages inside your inbox. So that activity would have a list, probably. There's a button on the bottom that the user can click to create a new email. When the user does click that button, right, there's some code behind that executes to navigate the user to the screen to let them write a new email. If the user touches on one of the incoming emails in the inbox, they navigate to another screen to show them the contents of that email. So those sort of two things together, the user interface with the list view and the button, plus those code behind event handlers, make up the messages activity. In the center, we have the compose email activity. And you can see there's a bunch of text views there and edit text that the user can fill in, right? The address and subject and so on. There's also several buttons. If you look up at the top right corner, there's the airplane icon to actually send the message. So again, we have that combination of user interface plus code behind behavior. And again, in this case, it's click handlers for things like buttons. On the right-hand side, we have the settings view, settings activity. And there's a bunch of static text, but there's also a few things that you can interact with. Towards the bottom, there's a checkbox. And when you touch or check or uncheck that checkbox, something happens in the code behind to record your preference. And once again, we have this nice combination of user interface plus code behind behavior. And each of these are for a single task. For example, in the middle, the task is compose a new email. On the right-hand side, the task is adjust your preferences. To help you think about the concept, let's do a couple of examples here. Suppose you were coding a music player app. Think about what kind of activities might be available within that app. So if you had to decompose this app into a collection of collaborating activities, what kinds of activities might you come up with? So here's some examples that we chose. Just think about the things that the user can do with the app. Right? They can define playlists. They can list their music by artist. Some apps allow you to play the radio. They can go to the store to acquire new content. And there's probably a currently playing view to let them do things like move forward or back, play, pause, and adjust the volume. Here's one more example. Suppose you were coding a contacts app. What kind of activities might you decompose a contacts app into? Here are the ones we came up with. You'd probably have an all contacts view that just gave you a nice, probably alphabetically sorted list of all the contacts. The user could touch one of the contacts to go to the details view and see details views there as well. There might be another screen to let the user edit one of the existing contacts with buttons like save or cancel, discard changes, whatever. And of course, add a new contact. So each of these is a task. Right? The first one is look at the existing contacts. The second one is add a new contact. Third one is look at the details of an existing contact, and so on. So again, the combination of a little bit of UI plus code behind for a single task makes an activity. Last question. Which of these is the best description, based on what we've talked about so far, for about how big an activity would be? Is an activity about the same size as a view, like a button? Or is it bigger than that? Is it more like an entire screen plus the code behind that goes behind it? Or is it even bigger than that? Is it several screens? So if you start in one activity and navigate, you might actually end up staying inside the same activity when you go to the new screen. So based on what we've talked about so far, B is the best answer. Just to get your intuition going, an activity is about the size of an entire screen. And when you navigate to a new screen in the app, you typically will be moving to a new activity. Some of this, of course, is a judgment call. If you're architecting the app, you get to decide where the activity boundaries, but just to set intuition, think of activity as representing about one entire screen, especially if you're dealing with a device like a phone. So one of the core things that you're going to do in Android when you're developing an app, and this is true for native Android and Xamarin.Android. One of the first things you need to do is decompose your app into activities. Our third task is to build the UI for an activity. We'll do this two ways, both by hand coding XML and using the designer tool. Here's some theory to get us started. So there's a base class called view, and everything that the user sees and interacts with in Android is called a view. The simple controls like button and text boxes and so on directly inherit from view. Composite controls inherit from view group, and there's two categories under that. There's collections like lists and grids. We're not going to talk about them in this course, but a later course covers those in quite a bit of detail. And then the other category under view group are the layout panels. And a layout panel is a manager. It owns a bunch of children, and its job is to calculate the size and position on screen of those children. Here's a more formal definition of view. So a view is something that the user sees on the screen, It has a user interface component, the part that the user actually sees and interacts with, and then typically it's going to have a little bit of code behind behavior, such as properties and events. Here's three of the most common views in Android. There's text view, which just displays text, edit text, which lets the user enter text that your app can then read, and button. Just a quick note on terminology. In this course, we're going to call these views. However, there's another term called widget, and the namespace for many of these views is actually Android.widget, and therefore a lot of people do call these things widgets instead of views. In general, the two terms, when you're talking about these user interface components, the two terms are synonymous. We're going to choose to use view because the term widget has another meaning in Android. It refers to the sort of mini app that you can pin to your home screen, something like the weather. And just to avoid confusion, we're going to avoid the term widget in the course. So a layout, it's a container, it's a manager that controls a bunch of child views. And its job is to calculate the size and the position for each one of its children. And it does that based on some intrinsic algorithm plus maybe a few hints that you supply. There's a lot of layout panels to choose from in Android. The most common, the most simple one is linear layout, which lays out your views in a single row or a single column. So for example, if I go back to the previous slide here, those views are laid out using a vertical linear layout. You can see there's a text view, and then below that an edit text, and below that a button, and so on. Another pretty common panel is grid layout, which lets you define a bunch of rows and columns and then slot your children into whichever row and column, whichever cell you prefer. There's also relative layout, which is actually quite a powerful layout panel. You specify how each child should be arranged and sized relative to the other children already in the panel. So for example, you might say, see this lower right box right here. So this view, you might say, I would like this view to be laid out to the left of this other view and below this top view. And I want it to be aligned with the right edge of its parent. So you add a bunch of constraints like that for each one of the views, and then the relative layout panel tries to satisfy all the constraints and lay out the children accordingly. The last one I'll mention is absolute layout. This is the one that gives you more control. So you do some math, calculate the position of each of the child views, and then the panel just listens to you as to where it should lay out the children. In this course, we're going to stick to linear layout. So to define a user interface in Android, and again, this is true for Xamarin.Android and native Android, you typically do it in XML. In Xamarin.Android, we use the AXML extension. In native Android, they just use XML. In either case, this is called a layout file. Right? It's a file containing XML that defines the layout of your user interface. And this is a pretty typical example here. You have a layout panel as your root, and then nested inside it, you have all the children. Once you create that layout file, you need to include it as part of your project. The layout file is considered what's called a resource. And a resource is just a file that doesn't contain code. Your project is going to have a folder, and the starter template already created this for you. Right? There's a folder named resources, and your layout files go in the resources folder. If we open that resources folder up, right, inside it's actually pretty complex. The first category of things in there, you'll see, are images. Android apps run on a wide variety of devices with differing screen sizes and screen resolution. So when you provide images for your Android app, each image, you typically want to provide it in a bunch of different sizes so that it looks good on a bunch of different screens. So all those drawable folders, that's all that's doing. It's just giving you a place to provide the multiple versions of the same images. And you can see the file names in each of the drawable folders are the same because they're the same image just at a different scale. And so the extensions there, the hyphen HDPI, that's high dots per inch, right? Medium, extra high, extra high, and so on. The whole topic of images and image sizing is an interesting one, but it's not one we're going to cover in this course. The next folder down is layout files, and that's the thing we're mostly interested in here. So there's a folder named layout, and inside there is where you have to put your layout files. There's one more folder I'll just mention briefly called values. Again, this is not something we're going to cover in detail in this course, but it's something that you'll see in your solution, so it's worth just a quick mention. So inside the values folder, you can put what you can think of as symbolic constants almost. So things like strings and colors, things that you don't want to hard code on the actual views in your UI. Especially things that might change or that might be used in multiple places. You can pull them out into XML files in the values folder and then apply them throughout your UI. If the value changes, you come update the XML file, right? You do the update in one place instead of updating it all throughout your UI. So in general, the idea of resource is an important one in Android. Resources are non-code files. Right, files that don't contain code. Our current discussion is only about layout files. Okay, so we know how to define a layout file and we know where to put it in our solution. To build the layout file, you can hand code the XML or you can use the design tool. So Xamarin has this design tool. It integrates with Visual Studio. It's also built into Xamarin Studio, so it's available in both. It has a nice drag and drop design experience. So there's a toolbox. You can drag new views or layout panels from the toolbox onto your UI. You can select items in the view in the middle there, and then use the property editor to change the properties. And so basically this is a graphical editor for the underlying XML layout file. So regardless of which way you choose to do it, behind the scenes, when you're setting properties in the property editor, or if you're editing the XML directly, what you're doing is setting attributes on the XML elements. So for example, the linear layout panel has an orientation attribute, and that can be either vertical or horizontal. A lot of the views, like text view, which is the static text, edit text, which is input text box, and button, they all have a property or an attribute named text. And when you're setting these in XML, if you start thinking about code behind that's underlying this, what this is really doing is setting a property in the code behind. Each of these types, like linear layout, text view, edit text, button, these are all types that were originally defined in Java and Android, and which Xamarin wrapped in a C# class. So by setting these attributes, you are setting the underlying C# property on the Xamarin wrapper for each of these views. One thing to be careful of, there's not an exact match all the time between the attribute name and the property name. The two examples that I have on the screen here, we do have a match. So lowercase o orientation sets the uppercase O orientation property, but that's not always the case. And it's often a good idea to read the Android documentation for each class. The Android documentation for each of these UI views has a table that tells you the names to use for the attributes in XML. Android requires that when you set an attribute, you prefix it with the Android namespace. And the Android namespace is this string right here, http://schemas.android.com apk res android. The prefix that we define, where we set this namespace, xmlns:/android, that string there, android, has no special meaning, and that prefix can be anything you want. So the word Android there, I guess I'm going to repeat this. The word Android there, it's not required, it's completely up to you. The thing that's required is the mapping to http://schemas.android.com, etc. By convention, everyone uses Android for the prefix name, and you probably should as well. So you need to define this prefix and then include it on every attribute setting. The prefix is not required on the element names. So linear layout, text view, those are elements in the XML. You could put Android : on the front of those two if you wanted to, but it's not required and therefore nobody does it. There are two important attributes that are required by most of the layout panels, and that's layout width and layout height. If you don't set both of these, you're going to get an exception at runtime. So you need to set values for both of these on every one of your views. When you choose values for width and height, the most common things to use are these two special values, match parent and wrap content. Match parent means make myself, in this case the text view, right? Make this text view the same width as its parent. And in this case is the parent is this linear layout right here. The other special value, wrap content, means, in this case, make this just high enough to fit around the text that it's displaying. So these two, match parent and wrap content, these are extremely common. You'll see these a lot, right, in width and height settings. In earlier versions of Android, there was something called fill parent. Android renamed that match parent, and now fill parent is deprecated. For the moment, they both work. They're interchangeable. They mean exactly the same thing, but going forward, it's probably considered better style to use the newer one, match parent, because fill parent is deprecated. So now we know enough to define the user interface for our activity. And we'll do part of it manually and part of it using the designer tool. So this is exercise number 2. If you'd like to work through this on your own, please go ahead and pause the video, go over to the instructions for exercise number 2, and go through the steps. When you're done, please come back and we will review the solution. So the first thing to do in this exercise is remove the unneeded part of the starter template code. Here I am in mainActivity.cs. We don't need that field, so I'm going to delete it. Delete that comment. And then down here, all this code that works with the button, we don't need that either. I'm going to go over to the user interface now, main.axml. And I'm going to remove the button that was included as part of the starter code. The template used the older fill parent. I'm going to update that to match parent. It's mostly personal preference. So now we've removed all the unneeded part of the starter code and we're ready to begin adding the new parts for our tip calculator user interface. So the user interface for our tip calculator is going to have an edit text, a button, and then 4 text views. Each one of these strings here, tip, total, 1.5, 11.5, each one of those is in its own text view. The first part of this we're going to do by hand coding the XML. So the edit text and the button we'll add by hand. And then those 4 text views at the bottom we're going to use the UI designer to create. Those views are arranged using linear layout panels. And we actually have 3 panels to do this job. We have a single vertical linear layout that defines the overall structure. And then nested inside that at the bottom, we have 2 horizontal linear layouts. So for example here, tip and 1.5, those 2 views are arranged inside a horizontal linear layout panel. And then total and 11.5, those are in another horizontal linear layout. So let's do this by hand at first. I'll start with an edit text. Since I'm using a linear layout, I must define width and height. So layout width. I'm going to choose match parent for the width. And for layout height, I'm going to choose wrap content. Underneath that, I'm going to add a button. And similarly, I have to define width and height. Button has a property named text, and this is the text that the button is going to show to the user. And I'll put something like calculate on the button. We'll use the designer tool to build the rest of the user interface. So I'm going to open the AXML file using the layout editor. And when you open it this way, or if you just double click on it, you get the two tabs on the bottom, source and content in Xamarin Studio, that let you flip back and forth between the XML source view and the design view. So in the design view here, I have a toolbox over on the side. If I collapse a few of these, you can see the structure. So in particular, notice there's form widgets, which has your basic views, and layouts for your layout panel. We need a couple of layout panels to start with. So here's linear layout horizontal. Let's grab one of those and drag it down here below the button. And if I open up form widgets, I'm going to choose a text view. Notice there are several different text views here. They just have different text sizes. We'll choose the plain text view option here. I'll grab it and drag it and try to drop it right on that horizontal layout panel. If you're not sure whether you did it right, you can look at the document outline view, drill down, see there's the linear layout, and then inside it the text view. So I did achieve my goal of dropping the text view inside the horizontal linear layout. I'm going to do the same thing a second time. And again, check it in the document outline view. Right? You can see that two of those are now children of that horizontal linear layout. If I select the first of those two text views and go to the properties grid here, I can edit the text. So the text property, I'm going to hardcode tip. For the second of the two text views, I'm just going to put a dash just so that we can see that it's not been set. The value will be populated from code behind once the user clicks on the calculate button. And now if I go over to the source view, you can see what we created here. So nested inside the vertical linear layout, I have a horizontal linear layout. So this nesting of layout panels is actually a pretty powerful thing. The UI design tool added IDs to all the views, and that's not something that we need right now. It's not something that we've discussed yet. It's perfectly fine to leave it if you would like to. It's not necessary yet though, so I'm going to delete just to make the XML a little bit slimmer. And another thing to do when you're here in the XML view is to just examine the width and height settings that the design tool chose by default and see if they make sense for you. I think they look good to me. Wrap parent and match content works in this case, I think. So this structure right here, that's this first part, tip and then 1.5. We need to repeat that structure for the second part. And you can do that using the design tool, or if you prefer, you can just copy and paste here in the XML view. In fact, the only change we need to make here is use a different hard-coded value in that first text view. And by the way, the tooling here lets you define the format that you'd like for the XML. So I've set up this to have my personal preferences, and if I go format document here, it's going to reorganize the XML into the structure that I prefer. If I go ahead and run the app now, you'll see that the user interface is approximately the way we want it. There's no behavior yet. If I type into the edit text and touch the calculate button, nothing happens. But the structure, the layout of the user interface is approximately the way we'd like it. So when we defined our user interface for the tip calculator, we used match parent and wrap content for the widths and heights. And those are actually pretty common. They're not the only option though. There's two other choices. Here's the first one. You can hard code values using pixels, points, inches, millimeters. So for example, the button I have there is always going to occupy 100 pixels. This style of layout is not recommended because your app won't adapt if it's run on different screens. So for example, let's say we have the button that we have there on the screen. We've hard-coded 100 pixels for the width. If we run this on a super high resolution display, like let's say 500 dots per inch, this button is going to occupy only 100 pixels. On a 500 dpi display, 100 pixels is 1/5 of an inch, so it's going to be a very small button. On the other hand, if we run this on a low resolution display, like 100 dots per inch, then our button is going to occupy an entire inch. So really the main point is, on different displays, our button is going to be different sizes, and generally that's considered undesirable. The UI is going to look very different on different screen densities, even screens that are of the same size but have different screen densities. So in general, this style of assigning widths and heights is not recommended, and instead you should use density-independent pixels. So density-independent pixels are abstract pixels. And the number of physical pixels they occupy is automatically adjusted by Android based on the DPI of the screen you're actually running on. And the goal is to make your UI elements, like this button in this case, occupy about the same amount of screen space regardless of the DPI of the screen it's running on. So in our example, let's say our goal is to have this occupy about 1 inch of screen space. On our 500 dot per inch display, we would want this button to occupy about 500 pixels. On our 100 dots per inch display, we'd want this to occupy about 100 pixels. Right? And that kind of automatic adjustment is what density-independent pixels enable. The baseline density is targeted at a 160 dpi screen. So this is basically just giving you a more precise definition of what a DP is. So one density-independent pixel is equal to one physical pixel only in the case where you're running on a 160 dpi screen. In other cases, if the screen is higher or lower resolution than 160, the number of density-independent pixels will be adjusted when it gets mapped at runtime to physical screen pixels. And by the way, the 160 number there is just historical. It's based on the DPI of the first Android device. So to make this more concrete, let's do just a quick one-question quiz. There's the button. Width is set to 100 dp. Suppose we were to run this app on a 480 dpi screen. How many physical pixels would this button occupy? So to figure this out, we use the conversion formula. The number of pixels is equal to, and that's px, the number of physical pixels, is equal to the number of density-independent pixels multiplied by some scale factor. And the scale factor is the screen resolution, DPI, divided by the baseline resolution of 160. So if we put in 480 for the DPI, and then divide that by 160, right, we get 3. And then we multiply 3 times the number of density-independent pixels, which is of course 100, to arrive at 300 pixels. And intuitively, I think that's about right. 480 is a fairly high resolution screen these days. It's not the absolute highest out there, but it's pretty high. And we would expect 100 dp to occupy more than 100 pixels on such a high resolution screen. And so again, the answer in this case is 300 pixels. So we finished creating the user interface, and notice we didn't even need any of the DP or pixel stuff. We can create a user interface that looks fairly reasonable just with match parent and wrap content. But DP is another good thing to know about. Those sort of three things together, the two constants and DP, are sufficient to build a fairly complex user interface. So we built our UI two ways. We hand-coded some of the XML, and we used the designer tool to do other parts of it. Our third objective is to write the code behind for an activity. There's several things we need to do. We need to actually look at the C# code behind file, look at the declaration of our activity class and make sure that we have one activity designated as our entry point. Then we need to load the activity's user interface. That doesn't happen automatically. We actually have to make a method call to hook up the user interface to the activity's code behind. And then finally, we can actually write the behavior of the activity. So that'll be code that reaches out and accesses the UI views to, for example, retrieve user input, subscribe to click events on UI buttons, and so on. So remember, there's two parts to an activity. There's the user interface layout file, and then there's the code behind. So there's the format that the code behind file has to take. So you write a class, in this case PyActivity. Your class must inherit from the activity base class. That's the way you become an activity. And you have to decorate the class with the activity attribute. So it's true that this looks a little bit perhaps misleading because that word right there is the same as that word. But remember, in C# there's an implied attribute word right there. Those are two different classes. One is the activity attribute, and the other is the activity base class. You need to make one activity in your app your main entry point. And you do that by setting a property on the activity attribute. So there, main launcher equals true. That makes PyActivity your entry point. To do your initialization, you're going to override the activity method onCreate. You're required inside there to call the chain to the base class, or you will get a runtime exception. In general, the onCreate override replaces your constructor. Legally, technically, you can still have a constructor. That's totally fine. The constructor will run before onCreate, but it's kind of rare. And in general, onCreate takes the place of the constructor. And the reason for that is a little bit subtle. You can see the parameter right there to onCreate, it's a bundle. There are cases where Android destroys your running activity and then recreates it. For example, when the device gets rotated. In situations like that, Android gives you a chance to save your state in a bundle and then passes that bundle back to you in onCreate. So gives you an opportunity to restore your state from that cached data. So this onCreate integrates with stuff we haven't talked about yet, with the activity lifecycle. And none of that's in this course, by the way. But that's the reason why you use onCreate instead of a constructor, because this integrates nicely with the rest of the activity's lifecycle. The other thing you're going to do in your onCreate override is set your layout, or instantiate your activity's layout. And to do that, you need to have some way of identifying your layout file. So remember, you wrote an AXML file. That layout file went in the layout folder, which went in the resources folder. So layout files are considered resources. So now what you need to do is write code that identifies that AXML file. Android actually makes it really easy for you to do that. You don't have to use the file name, you don't have to use the folder structure. Instead, Android automatically generates a symbolic constant that identifies that layout file. So there's the symbolic constant. It's based on the file name. So in this case, the file name was py.axml. So the extension gets dropped and just the base file name becomes the name of that integer constant. The nesting structure there, resource layout, that almost matches the folder structure. And in your code, you use the symbolic constant resource.layout.py to identify your layout file instead of trying to use the file name. This in fact is a really nice convenience. So now we know how to identify our layout file. This is how to actually instantiate it. So you're an activity. One thing you inherit from your activity base class is a method named setContentView. The argument is the identifier for your layout file. So you pass in that integer value, resource.layout.py, and then setContentView instantiates all the views in the layout file, and then takes that resulting instantiated UI hierarchy and loads that as your activity's user interface. In other words, it builds your UI and shows it to the user. So it's typical to call setContentView from inside your onCreate override. This is part of the core initialization for your activity. And really, almost every activity you deal with will have a call like that right in onCreate. The next thing we need to do is access some of our UI views from code behind. The first step in doing that is defining IDs or loading IDs into some of your views. So your user interface is basically a hierarchy of views. You have a layout panel, and inside that layout panel you have a button and an edit text and text views and so on. Some of those views have static things in them and you never need to access them from the code behind. Others, though, you do need to access from code. So the ones that you need to access from code, you need to set an ID, and then you do that in the XML, and then use that ID to look up that view from the code behind. So the view base class, remember, everything that the user sees, all those layout panels, buttons, all those things in Android, those are all views. They all inherit from the view base class. So the view class has a property named ID, okay, which is an integer. The fact that it's an integer is sort of an implementation detail, but it is mildly interesting. Think of this as a unique identifier for one of the views in your UI, and it's the thing that you can use from the code behind to get a reference to that particular view. Here's how you set it in the XML. So I have an edit text. An edit text is a view, so it has an ID property. In XML, I use lowercase ID to set the, we go back to the last slide, see how that's uppercase there, that property name? You go forward. I use lowercase ID to set the uppercase ID property on that edit text element. Remember that the ID property is actually an int, and when you're setting it there, it looks like a string. This first bit, @ plus ID, and then the slash, all that stuff's required. That tells Android you want it to generate a new ID for you. Anything after the slash, digits input, that's going to be used to generate an integer value. So see digits input right here? That's exactly what you chose after the slash. So behind the scenes, Android automatically generates that code for you. Android chooses this unique value over here, 2131034113. You don't have to worry about that. In your code now, you can use resource.id.digitsinput to look up this right here, this edit text in your UI. And here's how you do that. Again, you're an activity. So here's PyActivity is a activity. One of the things you inherit from the activity base class is find view by ID. And remember that ID is an integer, so the parameter you pass in is an integer. Resource.id.digitsinput, right? That's a symbolic constant, which is an integer. If I go back, that's this number 2131034113. And go forward again. So you pass in the integer value here. Find view by ID looks through the entire user interface for this activity. Think of the user interface as sort of a tree structure of these views and layout panels. So find view by ID traverses that tree looking at the ID property of each of the views. If it finds one, it gives you back a reference to that view. If it doesn't, it gives you back null. So this is the way from code behind you access the elements of your UI. You could look up a button And then from that, you can subscribe to its click event. In this case, I have an edit text that has a text property. So this lets me read the user input value just by doing et.text. So that brings us to the next lab exercise. So in this case, you're going to be writing the code behind for your tip calculator. If you'd like to work on this on your own, please go ahead and pause the video. And when you're done, come back here and we will review the solution. Let's work through the solution to exercise number 3. We're going to start here in the code behind. A lot of the work back here was already done for us by the starter template. For example, that right there, main launcher equals true, that was added as part of the starter template. We didn't have to write that code. So our main activity is going to be our application's entry point. By the way, this label here, that's displayed at the top of the screen when this activity is running. If you'd like to, you can put maybe a space in there to make it a little bit nicer. Down here in onCreate, this override of onCreate and the call to set content view, that was also part of the starter template. Our UI is defined over here in a file named main.axml, and then here, resource.layout.main, that's the integer, the automatically generated resource identifier that corresponds to that layout file. So we pass that to set content view. Set content view instantiates our entire UI and shows it to the user. Next, we'd like to go work on the user interface a little bit. So we're over here in the AXML file. We have several views in our user interface, and only some of those need to be accessible from the code behind. For example, we need to access that edit text. That's where the user enters the amount of the bill. From code behind, we need to reach out and grab that. Over here, we have a button. We also need to access that from the code behind so we can subscribe to its click event. And then down here, that text view is where we output the amount of the tip. And then down here, this text view is where we output the total, which is original bill plus tip. So those 4 views need to be accessible from code behind. Therefore, those are the 4 that we need to add an ID to. So we'll start here with the edit text. The syntax is @ plus ID /. And then after that, you choose whatever symbol you would like to represent this edit text. And I'll name it input bill, because that's where the user is going to input the amount of the bill. I'm going to do a similar thing down here for the button. Use a little copy and paste to save myself some typing. I'll call this calculate button. And then down here, this will be output for the tip, and then the last one here near the bottom, this will be output for the total. So now we're going to move back to the code behind, and we're going to define a couple of fields here to store references to the UI views that we look up. So we're going to have an edit text, a button, a text view, and another text view. And I chose to use the same words right here for the ID and the field names. That just lets me, in my brain, keep track of that. There's no requirement that you use the same field name here as you used for the ID. So down here in onCreate, we want to use find view by ID to look up those 4 things. Be sure you do this after the call to set content view, because set content view is where these things get created, so you can't look them up until after they exist. So we call find view by ID. It is a generic, so we need to say the type of the thing we're looking for. That means we don't have to cast the return value, which is quite nice. And then we pass in the resource identifier, resource.id, ID dot, and then it was input bill. Let me go ahead and build that. There we go. So you notice I wasn't getting IntelliSense, and sometimes that happens if you don't build after you define the IDs and before you come back here and start working with the code. So if you ever get that point, just do a build and you should be fine. And then I just need to repeat this pattern for the other 3 views. Right, and there's all 4 of the lookups. So now I have a reference to the calculate button, which means I can subscribe to its click event. So the click event uses the event handler pattern with the event args as the second parameter. So it looks like this. Object sender, event args e. Inside our click handler, we want to retrieve the user input. The input is coming to us inside this edit text. The edit text has a text property. That comes into us as a string, and we need to convert it into a double. Then we need to compute the amounts for the tip and the total. And finally, we need to display those 2 values, tip and total, to the user. And we do that using the text properties here of these 2 text views. If I run this, I'll enter a value for the input bill, click on the calculate button, and the tip 15% and then the total are displayed. In this section, we looked at the code behind for an activity. We started by verifying that our activity was actually designated as our entry point, and it was. That part was actually done for us by the starter template code. Then we saw how to load an activity's UI. And that's not something that happens automatically. In your code behind, you have to call set content view and give it the identity of your layout file. And set content view instantiates all the views in the file and then shows that UI to the user. And finally, we added some IDs to a few of our views in our XML and then used those IDs to look up the views from code behind. And that's how we, in the code behind, get access to our UI elements. Our last objective is to keep our development machine up to date as new versions of Android get released. We're going to talk about a few prerequisites before we get into the actual updating. It does help if you have a basic idea of the build and the deployment and the execution model for native Android apps and for Xamarin.Android apps. And the reason that you need to know about the native tools and libraries is because they get used by Xamarin in the Xamarin.Android build process. So a basic understanding of that whole setup will help you determine which pieces you need to update and when. So once we get the background out of the way, we'll actually update our development machine, install new versions of the Android tools, and the libraries. So our goal here is to survey all the tools and libraries that you need on your development machine. We're going to focus on the Android SDK when we do our updates because that part changes fairly frequently, and unlike a lot of the other pieces, it doesn't notify you when new versions are available. So it requires a little bit more of manual intervention on your part. Let's start our survey here with the Java tooling. So you need to have the Java SDK installed. The thing that you need from it is the dev tools, especially things like jar signer. That's used in the Android build process. Most of the other pieces here aren't used by Android. Those Java star libraries are not used. The virtual machine is not used. Android has its own. So it's just the dev tools that you need from the JDK. Then there's the Android SDK. And here you need both the SDK platform and the tools. Those are sort of the 2 core pieces. Yeah, there's some other libraries like the Google APIs, but those are optional, and we're going to focus on the required stuff. So it's the SDK platform, which is the core set of APIs or libraries. And notice that includes both the Java libraries and the Android libraries. So let me go back to the last slide. Notice that the Java star packages exist in the JDK. And then go forward here. The Java star packages also exist in the Android SDK platform. The ones here in the Android SDK platform are the ones that you use in your Android apps. And those two sets of libraries, the Java star packages, those are not the same in those two cases. The ones from the Java JDK, those would correspond to a Java edition like J2SE. The Android ones here, that's Android's own set of Java libraries, and those don't correspond exactly to any of the Java editions. And of course, you also have the Android star packages in there. And that's all the stuff that we've been discussing, like edit texts and buttons, and then all the stuff that you would use to access operating system services. So the libraries, it's your entire API surface area that you can call from your Android app. And then the build tools. So this is both build support, like there's compilers, and then runtime support like debugging tools in there. So those are also necessary to build and test your app. You'll also have the Android NDK installed. This is a little bit more specialized. It lets you write part of your Android app in a different language like C or C++. And this is a little bit outside the scope of the course, so we're not going to talk about it in any great detail. Just one point here. Google has an interesting use case. They say this can be useful if you have an existing C or C++ code base that you don't want to port over to Java, but you still want to make use of in your Android app. You also need Mono installed. So this is sort of the third category of libraries and tooling that you need to have. Inside here, there's several pieces. There's the base class library, and this is, if you're coming from the .NET community, you think of the .NET Framework class library, and over here in the Mono world, the base class library is the analogous thing to that. In addition, you need the compiler and the runtime. The Mono C# compiler is currently used to compile your C# code, and the Mono runtime is used to execute your compiled C# code. So the base class library, the C# compiler, and the runtime, those are the pieces that from Mono that you need on your development machine. Let's put aside Xamarin.Android for just a moment and talk about native Android development. So you start with a Java source file, and your Java source files go into the Java compiler and get translated into Java bytecodes, so you end up with class files. And then for Android, those class files are fed into a second compiler called the DEX, or Dalvik executable compiler, and then you get Dalvik executable files. Those Dalvik bytecodes, that's the executable format needed by Android. Those bytecodes are combined with all your resources, like your images, into a single file with an APK extension. And APK stands for Application Package. So that's the entire contents of your app ready for deployment. APK files use standard zip format, so if you're ever curious to see exactly what's inside, you can change the extension to .zip and just extract the contents. A quick note, there are a couple of other steps. So there's some post-processing you have to do on the APK file if you're going to deploy it to the Play Store, but you don't need to do that for just testing locally. To execute your app, the APK file needs to get loaded onto an emulator or a device. The current model has the DEX bytecodes getting compiled to native code at installation time. This is called ahead of time, or AOT, compilation. And Android is based on Linux. Each app runs in their own sandboxed process inside the execution engine, and the execution engine is called the Android runtime, or ART. Older versions of Android used a different runtime. It was called the Dalvik virtual machine, and the execution and compilation model was different back then. There wasn't an install time compile. Instead, there was a translation at runtime of the Dalvik executable bytecodes, the DEX files, into native code. So the common wisdom says that the new model, the Android runtime, is more efficient. So that whole story was native Android, without any discussion of Xamarin.Android. So now let's expand our focus here to include the Xamarin. So with a Xamarin.Android app, you write some source code in C#. And of course, that C# code gets compiled, and it gets compiled into an assembly. So this is the sort of normal build process that you might expect. You generate an assembly that contains IL. Xamarin has a post-processing step with the goal of making your application smaller. So in general, when you think of building and deploying apps to devices, you think of devices these days as still having a relatively limited file system and memory. So you want to make your app as small as possible. Xamarin.Android has a tool called the linker. It's part of the build tool chain, and its job is to look through all your code and all the mono code and just find the parts that you actually use. So all the classes you use, all the methods you call, all the properties you use, the events you subscribe to. All those things it keeps. Everything else it throws away. So you can think of it as a filtering process that slims down the assemblies to only the parts that you need. Only the filtered assemblies get packaged with your app and deployed to the device, so your app is smaller. One thing to be aware of with this, there's a couple of corner cases where the linker may not do exactly what you want. And the primary one is when you're using dynamic coding strategies like reflection. If you use reflection to look up a class and look up a member of that class and then use those services, the linker might not be able to determine that you're actually using that class and member, and the linker might strip those out. And then at runtime, your app's going to fail because you're calling something that doesn't exist in your application package. So you can control this. There's a preserve attribute that you can put on things in your source code to force the linker to keep more of the code than it might otherwise do. You can also disable linking in the project properties. So now we have assemblies containing IL code as part of our app. At runtime, we need a runtime engine, an execution engine that can execute IL for us. So the Xamarin.Android tooling feeds the entire mono runtime into the Android build process and includes that as part of your application package. On a device at runtime, you actually end up with two execution engines running side by side. You have the mono runtime, which is necessary to execute your IL code, and then you have the Android runtime, which is necessary to run the Java code, the Android libraries, right, all the native Android Java types. Let's do a short quiz to go over a few of the ideas. First question is somewhat motivational. Why do you need to know the stuff we just went over? The answer is that the Xamarin tools, behind the scenes, they use some of the native Android tools and even some of the native Java tools. So it helps to understand what's going on so that you can decide what pieces need to be updated on your development machine and under what conditions. So in addition to the Xamarin tools, what are the other things that you need to have installed on your development machine? And there I have listed the three sort of categories that we went over: the Java stuff, the native Android stuff, and mono. So the answer in this case is all of the above. And last question, does Xamarin.Android compile your C# code to Java and Java bytecodes in order to run it on the Android execution engine? True or false? And the answer is false. The C# code gets compiled to IL. At runtime, the IL is executed on the mono runtime. So all the stuff we talked about, your initial setup is quite painless because the Xamarin Unified Installer puts not only the Xamarin tools, but all the prerequisite stuff like the JDK, the Android SDK, and so on, onto your development machine. So it's not the initial installation that's tricky, it's keeping stuff up to date. And of all the pieces, the thing that's the most necessary for you to do manual updates for is the Android SDK. Within the Android SDK, there's two components that are critical. There's the SDK platform, that's your libraries, your API, and then your tooling. Both of these get updates relatively frequently, like on the order of every few weeks or every month. And the current generation of tooling doesn't let you know that updates are available. So you actually have to go out manually and check, and then decide which updates for these two categories you want to install. So Android comes out with new versions all the time, and to identify a version, you have three things. You have the code name, you have a version number, and you have an API level. For developers, the API level is probably the most critical thing because it exactly identifies the set of libraries that your app can call into. So when something happens that the API changes, like a new type gets added, new members get added, something gets deprecated, that kind of thing, the API level will change. So the API level integer exactly identifies a version of the libraries that you as an Android developer can target with your app. When it's time to update your Android SDK, you're going to use a tool called the Android SDK Manager, and it actually lets you update all 5 of those things. Again, we're focusing on the SDK platform, that's your APIs, and then the tooling that lets you build and debug an Android app. To launch the SDK Manager, there are menu entries in both Xamarin Studio and Visual Studio. Once you launch the SDK Manager, there are a couple of different areas to look at. The first one is the Tools setting. So remember, we're updating two things, the SDK platform and the tooling. Here's the tooling part. Android has split the tooling into 3 individual categories, just in case you wanted to update them individually. The common wisdom says that you should just always keep all 3 of these up to date. So whenever you see an update, the standard advice is go ahead and check off that box and do the installation. The new versions of the tooling are generally backwards compatible, so there's little chance of a problem with doing this update. For the SDK platforms, it's more of an optional thing. You only need to install the versions of the SDK platform that correspond to versions of Android that you want to target. And you can see in the screenshot here that there's an API level. Right? That's the thing that identifies which version of the API you're installing. So if you decide there's something in API level 22, some new service, new class that you want to start using in your Android app, then you would install the SDK platform for that API level and then target your application to use that version of the APIs. So our last exercise here is just to run through the update process. So please, if you'd like to work through this on your own, you can pause the video, go over to the instructions for exercise 4, and work through the update process. You'll update your tooling and optionally install a new version of the SDK platform. So please go ahead and pause the video, go work through that on your own, and then come back and we'll go through the solution together. Here I am in Xamarin Studio. On the Tools menu, there's an entry to launch the SDK Manager, and it'll just take a moment to launch and then contact the server to see what new things are available for me. So in my case here, I have one update in the tooling, the SDK tools. The other 2 categories, platform tools and build tools, you can see are up to date. So I just have one update there. And then if I scroll down below the tooling section and collapse this a little bit, you can see the different API levels that are available. So the latest released version at this time is API level 22. If I expand that, you can see the SDK platform I already have installed. If I didn't, I could check it off right here and then come down and click on the install button at the bottom. So in this section, we spent most of our time discussing the tooling and the build process for both native Android apps and Xamarin.Android apps. And the goal of all that discussion was, well, partly it was just a general understanding of how Xamarin.Android apps work, but it also should have made it easier to understand which parts of the tooling and SDK you need to update on your development machine. So our core goal here was to keep our development machines up to date as new versions of Android get released. And the two things that you need to do in that case are install new versions of the tooling and install new versions of the platform SDK. And the reason, again, that this part requires your attention is that both of these change relatively frequently, and the current versions of the tooling don't notify you proactively when new versions here are available. So you need to manually launch the SDK manager and check for updates. That brings us to the end of Android 101. Again, my name is Mark Taparauskis with Xamarin University. There's my email address if you have any questions. Thank you very much for watching.